Hello ladies and gentlemen, my name is Decryption and I hope you are well. In the last episode, we adjusted our AI so he can now do two roles. He can run to an area and hide, or he can try to seek us out. As part of that episode, because it was getting a bit long, we made it so he simply used a basic line trace to try to find us. So as you can see, he's running away, but he's using this line trace to try and scan us. In this episode, we're going to modify that now to use a perception-based system. So if he physically sees us, then he will spot us and the game will be over. So let's get started. So the only reason we didn't do this last time is purely because the video was getting a bit long for us to add all the logic into it. But you can see he's checking for us every time we do it. But realistically, we want him to see us at any point. So even if we start the game right here and he turns and sees us, he should immediately know, hey, you come here kind of thing. So if we come and open our state tree, at the moment we have this looking around node where it's got a search for player task on, right? And all that does is fire the line trace on tick every 0.5 seconds until the delay runs out, right? But instead of that, we want them to look around an area just for 5 seconds, but always be looking for us at any point, as long as they're seeking. We shouldn't really be doing it if we're not seeking. And the best place to do this is actually going to be the evaluator, because this runs against every node all the time. It's essentially a state tree tick, which is what we want. So I'm going to come back to my evaluators folder and I'm going to right click blueprint class and I'm going to choose state tree evaluator and we want the blueprint base evaluator. I'll click select, I'll call it STE underscore perception check for player. And I'm specifically calling that just so we know it is a perception test. It's not like a regular line trace or anything like that. I'll then come and override the on tree start and on tree stop. Because unlike the tasks, when the task hits it, these two run whenever the entire tree starts or stops. So if we call state tree stop, that's what will stop it. So inside here, we can go and get our normal details for our NPC. So we'll just add a variable for our NPC and we'll set it to my BP NPC. You'll set it to whatever yours is. Just a reminder, it is in your schema up here. So BP NPC for me and AI hide and seek. And I'll do the AI controller as well. And we'll set both of those to a new one as of 5.6 and 5.7. If you're on 5.5, set it to input. But we now have a new one called context. And we can do the same for the AI controller in the category of context. And we can do the same for the AI controller. And what this does, if we add it to our state tree, is it will automatically look for the AI controller and the NPC from up here, which is very nice. Just a minor note, if you are using the context, you need to make them named the same as these here. So instead of NPC, it will be actor. Instead of AI controller, it will be capital AI controller. And all this does is it just makes Unreal automatically bind them like there. So you can see the link icon, it automatically binds them to there. So you just don't have to set it. Alternatively, you can come in and just set it like normal. But now that we've got this here, we basically need to tell the AI to say, have a perception system. So if I come back to my AI now and we'll just load him up, we're going to come and add a new component to these called the perception, the AI perception. We don't want the stimuli source. That's if you want AI to notice something like a trap or something. We want the perception specifically. Then we're going to come over to the sensors config over here and we'll click add to add a new one. And we want them to be able to have sight. So we're going to add sight. We will eventually look at adding the other ones, like the hearing could be a good one. So if you run past them, they'll turn around and see you. But if you sneak past them, they won't. But for now, we'll do sight config and we'll open this up. And these are all the settings you can set to change how they view the world. What we'll do for now is we'll just hit compile and save, and I'm going to come back into the game. And what we're going to do is when we play it, we're going to hit the quotation key, and then we're going to modify the settings to change how they see. So you can see if we hit the quotation key, we can see currently the nav mesh, right? Do you see at the very top up here, we've got these numbers where we can turn on and off whatever we're seeing in the world. So at the moment, it's currently showing us AI details, behavior tree details, and smart object. The behavior tree, in this case, is our state tree as well, so it is nice to see what they're currently doing. So if we were to play it, you can see their current state is nothing because they're running. It's telling us bits what we need to do. Look, you can see it's seeking currently, and it's running to a random search point. Yeah. But if we come in and press the numpad keys to turn one off, you'll need to be playing this while you do it. So if we turn off AI and behavior tree and smart object, oh, he's already seen us. Look, never mind. But it'll stand there now. That's fine. But if we come and turn on the perception on number 5, you can see these massive green nodes here. And this is basically his sight. So you can see, he can see everything around here. He's got a massive view cone of what he can see. And if we walk into it, he will essentially see us at this point because we're inside this cone and then we can move out. So I've just moved him on down here and you can see this massive cone all the way around here. This is what he can see, where he stops seeing us and basically detects us. The red is where he will lose us, and the green is where he will detect us, and this arrow here is his actual vision cone. So you can see we can almost stand almost sideways to him and he would technically detect us. That's a bit insane, so we can tune that down to what we need. So I'm just going to set his sight to something like 1200. I'll set his lose sight to something bigger, like 1600. And instead of having his cone be 90 degrees of his entire body, we're going to set it a bit smaller to something like 45, 50, something like that. And we're going to make sure that detection by affiliation, we're going to tick them all. Technically, they don't do anything, but ticking them means they will detect everyone. We don't need to mark them as anything specific. But if you get into the C++ side, you can have more control of that. We don't need that level of detail, but tick them anyway. And then by default, you can set the dominant sense. So I'm just going to set that to sight. Just that's what they'll use by default. And we'll try it again. So we'll hit the apostrophe key. And you can see it's a lot smaller now. That cone there is the last time he saw us. And you can see if we hide away, ignoring the other line. Let's disable the other line trace. So I've just temporarily disabled the line trace he's going to run. And we'll press apostrophe. And you can see his cone over there is currently not detecting us at all. But as he runs towards us, you can see the circle now because he has seen us. That's where he's last seen us. But if we move away, you can see the age is ticking up. And that's because we've not given age an amount. So they're always going to remember this is where they last saw us. And the age is useful if you want them to try and patrol a specific area where they last saw you. But we can tune that down because we don't need them to remember all the places we were last were. So back on our NPC, let's just set the max age to something like 10. So for 10 seconds he'll remember our position, and we'll start it again. And we'll hit the apostrophe key, so you can see that age there is currently running. And when it hits 10, it will disappear. There you go. And if we get into his vision cone, because we're currently blocked there so he can't see us, let's make him actually see us. There. So you can see now, you can see I'm in his vision cone and he can see us. And he is updating for when he detects us. Because where there's a wall here, he's not seeing this, so I'm walking up here. As I get out of here, he's technically lost me. And the age is ticking up, so we'd make him run there or something. And as we get further away, he will eventually lose us. There you go. So he's currently stood there. If I was to run outside of this red ring, you will see it will stop. He physically can't see that far. So that's how the perception part works. It is relatively simple, and you can absolutely come in and customize it. But you can see now he has a wide view of what we are, but not as ridiculous as it was before. So now that we've got all that set up and we've tweaked the perception system to work for us, and absolutely go in and tweak it if you want him to see further or not, you can also customize these based on your character's ability. So if you've got a sniper rifle or an eagle who can see really far away, you can set that up. Or if you've got an old blind guy or a bat who can't see, you could potentially not have a sight source at all. But now we can plug into this component to do everything we need. So let's head back over to our evaluator, because typically when you follow a perception tutorial, they build everything on the NPC directly. But since we're using a state tree to connect directly to that and say, hey, if you spot the player, tell us, we want fine-tuned results. So on tree start, I'm just going to drag my actor in, and I'm going to get the AI perception component. So there are a bunch of events we can use to do this. So if we drag off our perception component and do assign, you see we've got a bunch of them here. The on component activated and deactivated are literally if you want to deactivate their perception. Maybe they're blindfolded or you're in dialogue so you don't want them to discover you. The on perception updated event literally says these actors are now in your perception. That's it. That's all they do. Might be good for a war game or something like that. The on target perception are more detailed ones. They give you specifically who's been discovered, whether they've left, whether they've come in, all that other good juicy info. The forgotten is if they've walked out of that red area, so you are no longer in their vision. And then the info and the updater pretty much do the same thing, but they wrap one in a struct with some extra info. So we're just going to go with the on target perception updated. You'll know you've picked the right one because it tells us which actor's been updated, and we've got the stimulus struct which we can break, and it will give us a bunch of details about what age it is and all other stuff like that. So we're going to connect that to on tree start like so, and I'm going to copy the actor and AI perception below, and I'm just going to unbind from that same event, because when our tree stops, we basically don't want to keep running this over and over again, so we're going to unbind from it for performance reasons, which is good. So the first thing we're going to do here is actually use this boolean successfully sensed here. And this is basically going to tell us, have we discovered someone new, yes or no? If we have, good, we can see them. So in our case, we'd run up to them and fail the hide and seek. On false, we haven't discovered them, or they've been forgotten, they've left our view comb. So we don't need to worry about that one too much. So I'm just going to select my stimulus and hide disconnected pins so we can do it like so. Next, we really should check what type of stimulus we're checking against. So if we drag off this and do get sense class for stimulus, and what this function does is technically this function here with the stimulus and the actor can be called from sight, hearing, touch, all of them. So we're just going to do a very basic check now, even though we've not implemented the others for safety, just to say, does it equal AI sense sight? You don't want the config, you want the sight one. And we'll just add another branch here. And at this point, we could probably check if we want to check if it's the actual player, which will probably be a good idea. So I'm just going to drag this over here and do equals, and we'll just make sure this equals the get player pawn, because in this case, we are only checking for the player. And we'll add another branch here. So just to clean this up, we can wrap all of this in a function instead. So I'm just going to cut that, delete this off, and instead I will do create event, and we will select create matching function, and then we can paste this back in here. And this is just tidying it up a bit, so it means over here we can just drag off of here and do get stimulus. We don't need to create variables to hold it. And then over here we can also just do get actor to get our variable here. So this just cleans it up a lot. So now this function, whenever they discover or see the player, will be called. It will first check, have we actually seen the player, or are we reporting that we've lost them? Well, we don't care that we've lost them in this case, so we're just going to keep making them do whatever they're going to do anyway. This one will check if they've actually used their sight to see us rather than hearing or touched or whatever. We will break onto the hearing in another video. And then we're just double checking, is it actually the player we're concerned about? If it's false, we can ignore it. If it's true, then we've pretty much got everything we need. We now know that we've found the player. So how can we essentially say that now that we've found the player, that the state tree should essentially jump somewhere else? Because at the moment, we're doing it as part of this individual task. If the NPC is running to a location, we need to scrap that and jump straight to player found because they found the player. And what we can do is a mix of evaluators passing an event or a delegate, which we looked at last time, and we can use global transitions, which is really cool. Because as a state tree goes down, we can hold on to transitions from the parents in order to run something. So I'm thinking on is seeking, we'll add a transition event here of has discovered player, and no matter what it's doing in here, as soon as it discovers the player, we can make it go straight down to player found and run the little bits it needs to. So back on our perception check for player, we did use the delegate one last time in our task, but this time we're going to, just to change it, use the send event, which is pretty much the exact same thing. We'll promote it to a variable and we'll call it on player scene, and we'll make it instance editable. and we can hit compile and save, and you'll notice we get one error. That's simply because our onTree stop needs to be pointing to the new function like so. And then back on our state tree, we now have this onPlayerSeen event here, where we can add specific tags or anything if we want to send it across, but we don't need anything passing. We just need to basically say, hey, it's done. So we've got our event here now where we can specifically say, on this event, run this logic. It is a little bit different to the delegates, and the reason we're not using the delegates in this case is evaluators don't actually have access to the delegate section. That is only for a task. So that's why we're using an event on here to say, hey, the player has been seen. So all I'm going to do is come and add a gameplay tag, because that's built into state trees, and I'll go to my states logic, and I'll just do add subtag, and I'll do AI dot target seen, and I'll just do add new tag, and I'll make sure I tick it. So this event is currently checking when this tag of target seen with no payload, and the origin will just set to something like perception check for player, just so it's got something unique on it. And then on our is seeking here, we'll add a transition of a type event, and our required event is when the target in the states AI target seen. So when the target has been seen, we're going to transition to player found, just like that. We don't want to delay it in any way or add a condition. We just basically want to say as soon as they see the player, run towards them. We could technically add a condition if they're already at the end, but I think at any point in hide and seek, until they physically stop the tree, they can check for the player. And then back on looking around, we can now actually remove the delegate check for when the player's found, and we can technically remove the search for player. So now the way this should work is any point if they see the player, they'll run straight towards them. And when they get to an area to look for the player, they'll look for around 5 seconds, then they'll move on. So let's give it a try and see what we do now. However, I am going to move my player start just over here, so it's out of sight, out of range, so they can't see us straight away. So if we try it this time, if we press the apostrophe key, we can see he's running over to there. If we come and hide here so he can't see us, and we'll make sure we stay hidden, we're looking good. We might have to increase his vision code, because he should clearly be able to see us from here. But you can see now that he sees us, it has spotted us, but he's still running to the other area, but then he'll immediately run back to us, look, because he's found us. And this is simply doing it because he currently has a task to run from there to there. We need to tell him to temporarily think about that task. Hey, interrupt it and just check if you need to do it again. So we can simply do this on here to make him cancel out of this task by either adding a transition for the event into this one, so it gets it and then cancels it straight away, or another easier option is back in our perception check. Let's just make a bit of space here for when the player's seen, and we'll just simply tell the AI controller to stop movement. And all this is going to do is just trigger them just temporarily to say, hey, just rerun your checks, and then they'll immediately run towards us. So if we play it now and run towards them, we can see we're currently hiding. He can't see us. He's looking for us. As he runs towards us, he snaps towards us, runs up, and here we are. He's found us. That's it. He saw us as soon as he was running, so much better than before. However, I do think he needs to be improved view-wise, so let's go and increase that. So back on our BP NPC perception component, let's set this guy's sight radius for hide and seek at least to something like 2000. And the loss sight, it doesn't really matter, I'll set to 2500 because we're not worried about a loss on here. And we'll play it again, we'll just double check. He pretty much should be able to see us from anywhere in here. That's what I want, essentially. Yeah, so he can't see us at the moment, but then he will see us and run straight towards us. He's found us. So I'm probably going to increase that a little bit bigger, like so. When we start the hide and seek, we will dynamically set this to make it match it, because you don't want them all seeing you from far away. But the point is, you can still not see him there. If we stand behind him now, he will no longer detect us, which he did before. But if we try to hide over here, oh no, he saw us, he's going to run towards us, or he's found us. He ran to our last location because that's where he's set up to, but he has indeed found us. See? How cool is that? And one other thing you might notice with the logic is currently we've set him that when he sees us to mock us and just stand there for 90 seconds. But you'll see he will kind of run up to us. So you'll see he'll run towards us, and as we move around, he'll eventually run up again, like so. And that is simply due to our evaluator retelling him that he keeps seeing us. Because the event is essentially refiring and saying, hey, he's found again, hey, he's found again, and he just keeps running towards us. But an easy fix for this is we can pretty much just tell it to ignore the evaluator if we've already seen the player. So back on our isSeeking node here, on the event, we have this conditions flag here. So we can pretty much add a condition into here to say, hey, don't do it again if you've already done it. So an easy way around this is we can just tell the evaluator not to trigger the event if they've already seen the player. So back on our perception check for player, all I'm going to do after we've sent the event here is I'm essentially just going to tell it to call the same logic as on tree stop. We unbind the event, so it won't check anymore. So I'll add a custom event just above this called force unbind perception. We'll connect it up, and then back on our function at the very end, once we've sent the event, we will just call force unbind perception, like so. So essentially, this evaluator will basically stop doing anything after they've seen the player for the first time. So if we run this time, apostrophe on them, we can see that they are checking, they're looking that way currently. They can now see us, they'll run up to us, and that's it. No matter where we run, they will essentially just stay right there. The evaluator is saying, hey, we've done our job, they know where the player is, that's it. How cool is that, ladies and gentlemen? We now have a proper hide and seek system. There's still plenty more we can do to it to make it really, really cool, but it is coming along nicely. So in the next tutorial, we're going to wrap all of this up in some nice logic so you can run up to them, talk to them. It starts the game, gives you a time countdown for you to go and hide. We'll do some dialogue. We'll even give it the option so you can choose whether you want to seek or find. How cool is that going to be? So thank you for watching. I hope this was helpful. If you've got any suggestions of what you'd like to see, please let me know. My name is Decryption, and I will see you next time.